So in this video, we're going to introduce the idea of averaging here. So we just did a probability distribution, and so this is a copy of the probability distribution we came up with and the histogram that goes along with it, where X represents the number of children in a family. But what if you ask the question, what's the average family size, right? So this is known as the mean or expected value. The expected value is denoted as E of X, which is equal to the sum over all X of the value multiplied by the corresponding probability of the value happening. Okay? So how would I do that with this one here? The mean, or the expected value here, is equal to the sum of the x's. So the first one is 0 and 0.11. So 0 times 0.11 plus, sigma means plus, and then the next one, 1 times 0.32, 1 times 0.32, plus the next one, 2 times 0.39, 2 times 0.39, plus 3 times 0.10, 3 times 0.10, and then the last one, 4 times 0.08. And if I do that into my calculator, type it in, what do I get? I get 1.72. Okay? So what does this mean? What is 1.72? It's the measure of the center of mass of the population. It's the theoretical average. Now here's the deal, guys. You can't have 1.72 kids, right? So sometimes your expected value comes out to be a number that is impossible to attain, okay? You can't have 1.7 kids. You can have 1 kid, you can have 2 kids, you can have 3 kids, you can have no kids. But this is like the number that you expect to see happen if you did this trial thousands and thousands of times. It's kind of like that long run average, okay? It converges in the expected value. I would expect 1.72 kids, meaning, I'd expect either 1 or 2, but more likely I'd expect 2 kids in a family than 1, because 1.7 is closer to 2. That's kind of the idea there, okay? So that's how you get the average, the mean, okay? And just like we have in the past, once we talked about mean, then we talked about variance. And so how does the family size vary? How does the family size vary? That's with the variance. And the variance is sigma squared equals the sum of x minus mu squared times the probability of x. So it's the deviation squared multiplied by the corresponding probability over all x's. Okay, so these are my two formulas right here. Right here and right here. And now that's for that's for a variance. For standard deviation, I literally take the square root of the variance to get sigma. So I take the square root of my answer. Okay? So this is equal to the square root of all that there. Now, how do I do that? Well, let's drag our table down, because this is what I need to get this done. Okay. And I think I had a mu equal to 1.72, right? That was my mu. So let's make this a little bit smaller. Okay. So what do? So the variance is equal to the sum of the x value, the first x value 0, minus the mean 1.72 squared multiplied by the probability, plus the sum of the x value, which is 1 minus 1.72 squared, times the corresponding probability, 0.32. Plus, now the next value is 2 minus 1.72 squared, times the probability that goes with that is 0.39. And then plus 3 minus 1.72 squared times probability 0.1, and then plus 4 minus 1.72 times probability 0.08. And if I type that in my calculator, I'm going to get like 1.1016, and then the square root. Okay, sigma is equal to the square root of 1.1016, which is roughly 1.0495. So that's the standard deviation. Now, how would I interpret this? The family size varies, looks like, by about one kid. Okay, so 1.7 kids plus or minus a kid. All right, so some families have 1, some families have 3. Between those two ranges, that's a variation, one standard deviation. Okay, so that's the idea of how you would get your mean, your expected value. Okay, and how to interpret the expected value. It's the long run average, what you expect to see over a long period of time, and then the variance, how the family size varies.